All right, gentlemen, video number 3 for bonding and grounding. This one will probably hover, these last two will probably hover somewhere in the second half of this week's module because they are definitely dealing with chapter 2. Brief summary of what we've gone over so far. Um, we have our grounding system that we're building from the ground up, literally. Our grounding electrode system is what ties us to the earth and is for lightning and surge dissipation. Then we have our bonding jumper, which ties our grounding electrode system into the most important safety feature of any electrical system, and that is the equipment grounding system. The reason we have a bond, I've already mentioned once, it helps to stabilize our voltage. And the second reason is that if lightning or surge energy enters our system at any point, then we have a low impedance path for that lightning or surge to dissipate to the ground. If we didn't have that, then it would try to leap, right, and arc out to create the connection to ground. Excuse me. So, equipment grounding conductors are a little bit different than the first two I mentioned, um, mainly because they serve a different function for the most part. And that function is to provide that low impedance path in case any part of our electrical system that has potential ends up touching any metal or person that it's not supposed to be touching, and create an electrical circuit. So, equipment grounding or ground fault circuit paths uh, are what we're aiming for here. And because we are protecting our conductors with breakers, um, then we already know there's only that much potential for amperage. And so if you'll look at the chart I'm showing now, which is 250.122, you'll see that our equipment grounding conductors are based on our breaker size. Uh, and that does two things. One, I've already mentioned. The other thing is it makes it easy to build cables, right? Because then manufacturers know, well, I need to put a number 10 into a number 8 Romex, a number 10 bare copper into a number 8 Romex. And then, of course, the other reason is because we only need to carry the maximum fault current for a very, very brief moment. And hopefully it's instantaneous when it opens. And so I wanted to trace the ground fault current path for you. And some of the slides show this very well. And then I guess I also ought to mention how grounding light poles is completely dumb because they have an equipment grounding conductor. But anyway, say you're say you're one of your hot phases comes loose, wire comes loose on your dryer plug, and it's touching the housing of the dryer. Well, if you didn't have a ground fault circuit path in place, then that would just sit there until it found a way to get back. So if you had your water pipe ground and you walked into your laundry and the floor was a little wet and you were stepping on the metal drain and all your pipe was metal like it is in my house, all of my pipe underground is metal, uh, you could become part of that ground fault current path. And if that electricity flows across your heart, well, it's you have better odds of getting of getting attacked by a shark than surviving something like that. Of course, I'm exaggerating. So the main difference between grounding electrode systems and bonding jumpers that are sized based on service entrance conductors and equipment grounding conductors is that equipment grounding conductors are sized based on the breaker size for the circuit that they are protecting. Um, so this gives me time to go over it because we drilled this in my second year class pretty well. Um, I would call out what table sized what thing and what was used to size it. Obviously, I can't drill you like that, but if we work from the ground up, we have our grounding electrode system where part 3 tells us how to build a grounding electrode, whether that's a UFER or a ground rod or a water pipe. Okay, then we have to size the conductor that's connecting it to our meter base. And for that, we use table 250.66, and it's sized according to the service entrance conductors coming in. Okay, then we build a separate system that's going to protect all of our equipment. All right. And since it's past the main breaker, we're going to use breaker size and tables 250.2 250.122 to size those. So we have two separate systems, one for equipment and personnel safety and one for lightning dissipation. And we're going to connect them together in the middle with a bonding jumper. And for that, we use this new table, which is 250.102C1, I believe. I can scroll up to it because I took him in order. Yep, C1. And the only difference between 250.102C1 and 250.66 is that when we get up into larger sizes of service entrance equipment, then we're asked to make the bonding jumper at least 12.5% the size of those conductors coming in. So in a typical house, that's funny because now the typical house is probably pulling in 200 amps. But back when I started, when the houses were all being fitted with 100 amp meters, we would pull in by a special chart in the code book. We'd pull in number 2 copper. No, I'm sorry, it was number 2 aluminum. But you could use no, yeah, it would be number 2 copper if you used copper. And number 2 copper barely handles 100 amps, but there's like some load calculation things in there that allow for it to happen. And you'd pull that in, and if that's what you had, then you would look at the chart and you would see 2 or smaller requires a number 8 bonding jumper, and you would take the big green screw in the meter base and you just run it through because that's bigger than a number 8, right? And because it's listed to make that main bond. And once you did that, you would be tying all the grounding past the meter with all the grounding before the meter. And again, like I said, the aim would be to provide a low impedance path back to the source if it was a ground fault, or back to the earth if it was lightning or a surge. So hopefully these videos kind of helped. You can watch them over again. I honestly feel like I'm pretty boring doing them. I would much rather be in class because I'm a lot more animated when I'm walking around using my hands. But if you have any questions, again, just make sure you email me or join in one of the online office hour conferences and ask away. But again, thanks for your time.